My name is Dr. Fahad Ijaz, and today the topic of presentation is reflection of light. By the end of the presentation, the participants will be able to define reflection of light, describe the laws of reflection, differentiate between a real and a virtual image, describe the reflection of light in plane and spherical reflecting surfaces, and describe the image formation in convex and concave mirrors. Uh, Anybody has an idea what is reflection of light? Anyone?
When the ray of light again encountered the surface, it reflects back into the same
Yeah.
medium.
So basically, what happens is when the light meets an interface between the two media, its behavior depends upon the nature of the two media involved. So the phenomena of the bouncing back of light into the same medium, that is called as a reflection of light. Light may be absorbed into the new medium, or it may be refracted away from the other medium. So the nature of the behavior of the light depends on the nature of the two media involved, and the bouncing of the light at an interface is called as a reflection. Now, there are certain laws of reflection which will be covering. The first of all is that the incident ray, the reflected ray, and the normal to the reflecting surface, they all lie in the same plane. And the normal basically is aligned perpendicular to the surface at the point of reflection. And the other law states that the angle of incidence is equal to the angle of reflection. Angle of incidence equals the angle of reflection. So if you can see here, this is the image. As I told you earlier, the incident ray, the normal, and the reflected ray, they all lie in the same plane, and the angle of incidence equals the angle of reflection. Now, reflection at irregular surface, when that was at a regular surface, and now coming back to the reflection at irregular surface, when a parallel light encounters an irregular surface, it is usually scattered in many directions, and this is called as diffuse reflection. This is the image showing that light is striking at multiple surfaces, and basically this is not a regular surface, so that's why it is scattered in different directions. This is known as diffuse reflection. Now, a very important concept, reflection at a plane mirror. Light from object O is reflected at the surface according to the laws of reflection. I'll come to a figure. This is a figure. This is the object that is placed, and this is a reflector mirror. When the rays of light, they are incident on this surface, they are reflected back towards the same media. But what happens is our brain basically, it tends to perceive image as it is. The brain always assumes that an object is situated in the direction from which light is entering the eye. So what happens is that our brain tends to assume that the image of this object is perceived to be here. The object is here, the rays of light, they are reflecting back towards the surface, but our brain assumes that the image is situated over here. So basically, what this is a virtual image, because the rays of light, they are not meeting at a surface, but when we draw the rays of light towards towards the back of these reflected rays, this is the image is positioned here. So this gives us the concept of a virtual image. Basically, the difference between a real and a virtual image is a virtual image cannot be formed on a screen, whereas a real image is can be formed on a screen. I'll explain it with more examples. Images that could not be captured on a screen, they are such images are called as virtual, whereas that can be captured on a screen are called as real images. Now, again, reflection at a plane surface. If you can see here, this is the object AB. The rays of light incident on this surface, they are reflected back. The eye seems that the image is located somewhere over here behind the mirror. So basically, the image over here, this is a virtual image. It is a real image. Sorry, it's a virtual image. It is an erect, virtual, and laterally inverted image that is perceived by the eye. As I told you earlier, it is an upright, virtual, and laterally inverted image that is formed at the plane surface. Now, reflection at spherical reflecting surfaces. Basically, a reflecting surface having the form of a portion of a sphere is called as a spherical mirror. There are two types of surfaces. I'll just explain. We have two surfaces, convex. This is the convex, and this is the concave surface. Concave mirror. So basically, these are the two types of mirrors which we'll be covering in this presentation. If the reflecting surface lies on the inside of the curve, it is a concave mirror. So if you can see here that this is the inside of the curve. So if the reflecting surface lies on the inside of the curve, this is a concave mirror. Means that the reflecting surface lies on the and if the reflecting surface lies on the outside the curve, now this is the convex mirror. Now in this case, reflecting surface lies on the outside of the curve, so this is a convex mirror, and if it lies on the inside of the curve, that is a concave mirror. Just to show the examples, now this is the concave mirror, implying that the reflecting surface lies on the inside of the curve, and this is the convex mirror. I'll later explain the behavior of the two different types of mirror that is involved. Rays parallel to the principal axis are reflected towards the concave, and they are directed away from the convex mirror from the principal focus. Now if you can see this image here, rays of light parallel, this is the principal axis, this is a focal point, principal point in the center of curvature. If you can see here in a concave mirror, when the rays of parallel rays of light, they are entering, they are striking this concave mirror, they are reflected towards the principal focus. So this is an important differentiating point between the concave mirror and a convex mirror. And if you can see here, the parallel rays of light parallel to the principal axis, they strike this mirror at the at the surface, they are reflected away from the principal focus. So this gives us the phenomenon of convex mirror, and this is the basic differentiating point between convex and a concave mirror. Whereas the C is the center of curvature, as I told you, the center of the sphere, the mirror part, and the pole of the mirror, and CP is the radius of the curvature. Now, image formation by the convex and the concave mirror. The image formed by the concave mirror is real, while that formed by the convex mirror is virtual. Now I'll explain this phenomena with the help of a few examples. The following diagrams will show the nature and situation of the images formed of objects which are at a finite distance from the mirror on the principal axis. And in each case, I'll explain the examples with the help of two rays. A ray that is parallel to the principal axis and reflected to or away from the principal focus, and a ray from the top of the object passing through the center of curvature and reflected back along its path. Now, these are the three different examples that I'll explain. This is the object. Now this is all a concave, the examples of a concave mirror. If you can see here, when the object, this is the principal focus, center of curvature, this is the principal axis. So when the object is placed outside the center of curvature, we'll construct these diagrams using two rays, one that is parallel to the principal axis and one that goes directly to the center of curvature. So if you can see here, one that goes directly parallel to the principal axis, and then in a concave mirror, as I told you earlier, that it is reflected towards the principal focus. So image will be formed over here between the center of curvature and the principal focus. And now anybody can explain what are the characteristics of this image? Yeah, exactly. Now if you can see here, the two lines are meeting. This is a real image. As you can see here, the size is reduced, so it is a diminished real, and it is inverted image. Now when we move this object from between, now it was placed outside center of curvature. Now if we move the object between the center of curvature and the principal focus, now anybody can explain what the difference is? Yes, well, exactly. The point is that again, two rays of light parallel to the principal focus and then reflected along its path, and the image is formed. But the difference now here is it is a magnified image and it is formed outside the center of curvature. Now a very important example over here is when the object is placed inside the principal focus, what will happen to the image? If you can see here, when the object is placed inside the principal focus, rays of light do not meet over here. So what the image will be called? Virtual image, because it is, yes, virtual, magnified and erect, because the fact that the rays of light are not meeting over here, so we have to draw this image and it will be not be formed on the screen. It is a virtual image, enlarged and real. Sorry, virtual, erect and enlarged. Now image formation by a convex mirror. This is the image formation by a convex mirror. The object may be located at any distance from the mirror, but if you can see here, there's, as I told you as well, that image formation by a convex mirror cannot be real. So again, rays of light, one parallel to the principal axis, and now as I told you earlier, they are reflected away from the mirror in the case of a convex mirror. So rays of light parallel and reflected back, and they meet over somewhere over here. So it's a virtual, diminished and erect. And magnification of image, it is basically the ratio of the image size over the object size, and it can be easily calculated using the formula image over object, or distance of the image from the mirror and distance of the object from the mirror. Thank you. Okay. So
So what are the practical examples? ये कॉन्वेक्स मिरर और कनकेव मिरर आपको कहाँ कहाँ पे नज़र आते हैं एवरीडे लाइफ में? ठीक है, वो सड़कों पे भी एक नज़र लगे होते हैं टर्न के ऊपर, उसका क्या मतलब?
कौन सा मिरर होता है? कॉन्वेक्स। ठीक है, अच्छा। और जो आपका हाइंड व्हील्स का जो आपके बिलो या जो आपका मिरर होता है सामने बैक व्यू मिरर, रियर व्यू मिरर, वो कैसा?
और कोई इसमें ऑफ्थल्मोलॉजी में कहीं पे यूज होते हैं मिरर्स?
कहाँ होता है? किस चीज को रिफ्लेक्ट करने के लिए?
बेसिकली वो मिरर ही है जो हम ऑब्जेक्ट लेके जा रहे होते हैं, वो उससे रिफ्लेक्ट होके इमेज
कितनी डिफ्लेक्शन होती है?
90
3 में 90। अगर हम कॉलम को टिल्ट कर दें तो चेंज चेंज।
गुड। और
प्लेन भी आता है, कनकेव भी है, कन्वेक्स भी, तीनों होते हैं।
और गोल्डमैन 3 मिरर, उसमें कितने मिरर होते हैं? 3 मिरर्स और 1 लेंस, सेंट्रल लेंस और तीनों इर्द गिर्द। और रिफ्लेक्शन कहाँ पे आप एनकाउंटर करते हैं ऑफ्थल्मोलॉजी में? गुड। कौन सा टेस्ट होता है जिसमें ये परकंजे इमेजेस देखते हैं हम? ये डिस्प्लेस्ड है कि सेंट्रल है? हर्शबर्ग टेस्ट। ओके, ठीक है। सो whenever light strikes the interface, some of it is reflected back. What happens to the rest of the light? ठीक है, so कुछ एब्जॉर्ब हो जाएगी और कुछ जो है वो तो what is anti reflective coating?
1/4 ऑफ द वेवलेंथ पे हमें कोटिंग कर देते हैं, जिससे डिफ्रैक्टिव इंटरफेरेंस होती है और जो रिफ्लेक्शन है वो मिनिमाइज होती है ताकि एक क्लियर इमेज।
Excellent. So you can decrease the reflection by the use of destructive interference. Okay. So और कोई एक रिफ्लेक्शन हो गई, एक एब्जॉर्प्शन हो गई, और तीसरी चीज क्या? रिफ्रैक्शन।
और एक और भी
splitting of light
तो लाइट स्पेक्ट्रम है का पूरा है, किस कहाँ से फ्रीक्वेंसी क्या है, किस फ्रीक्वेंसी 400 to 700। इसमें मैक्सिमम जो यूज करते हैं कौन सी लाइट का?
555।
तो ये ग्रीन लाइट है, ये कहाँ कहाँ है? एक रेड लाइट यूज होती है
जो यार केबल फोकस करने के लिए रेड लाइट कलर
मार्कर कहाँ किस जगह पे आते हैं।